Hi, Cal Gray, Process Vision, Richmond, Virginia. Let's look at the OptiCount vision-based seed analyzer with more detail on our innovative treatment appearance rating system. We introduced the OptiCount product line in 2011 to provide real-time count per pound data to support the move to sale by count in soy and corn. The OptiCount Online can run product from your inline sampler as frequently as every 2 minutes and give a continuous stream of data on count per pound, but also data on size and shape variability. We followed almost immediately with the OptiCount Lab, the smaller and less expensive benchtop version. It has been configured to analyze corn and soy, but also everything from canola and a wide range of veg seeds to edible sunflower kernels to plastic pellets. To cover this wide range of applications, we offer 3 lens stage configurations: the full 16-inch by 12-inch stage for count-only applications, 11 by 9 for color analysis where even illumination of the image is required, and 8-inch by 6-inch or even smaller for very small objects like canola and very, very small seeds like tobacco. A fundamental design principle in the OptiCount family is the use of vibration to settle the sample to a uniform orientation before the image is taken. With the product settled and resting in this position, meaningful geometric analysis is possible. We can be certain that an oblong is truly an oblong and that the hilum of a soybean will always be to the side, something that in-flight imaging simply can't assure. Knowing that the longest dimension that we measure is truly the major axis, these formulas allow us to make meaningful comparisons of volume and surface area for each of the objects in the sample. We have always said that variability was the enemy of quality. It is surprising to see how much variation there is in the volume and surface area for soybeans that don't seem to be that different in size. And nowhere is this more important than in the application of treatment to the surface area of the bean. Compare the 5 millimeter and 7 millimeter statistics in the table below. Treatment application is a surface area process, and we believe that surface area statistics are more important than you realize. Yes, even more important than count per pound. In addition, we accumulate variability statistics for all of the parameters that we measure. You can see there are a number of parameters for which these are really important. The size and shape statistics are valuable, but we believe that our unique color analysis methodology is even more important. As you see in these treated soy samples, we quantify appearance based on color measurements down to the individual pixel level on every individual bean, as many as 1,800 pixels on the average bean. No more qualitative ratings like good, acceptable, marginal, and I hope that hasn't been shipped yet. The data tells us how much variation there is across the sample from bean to bean to bean, and when we have splotchy coverage within each bean. Finally, a truly quantitative appearance rating system. Let's run a sample. You see that we have started the application. We're doing some self-checks. We tell the system we will run from the scale. We enter a sample name. And when we do that, we get a threshold image. We click Next, and we read the scale. You see the scale weight shown at the top of the screen. We have 145.42 grams. We pour the sample on the stage and spread it out. We're going to vibrate, so we'll get the individual little pockets settled out, but we want to make sure there are no large pockets. We click Next. You see the sample vibrate. The backlight is on. We're taking the backlit image, and there you see the backlit image. You see the lights flash to take the image from above immediately. We've made the calculations, we present the final image, and the sample is complete. We have count per pound, statistics, all the data. We empty the stage and we're ready to run again. We're going to run again to show you, give it one more chance to look at it. There's the sample name again. That can be any text or number, could be barcoded in. The threshold image is to show what the stage looks like with nothing there. Then we take a picture with the product. The difference between nothing and something is the product, and that's how we know for sure that we have only the product calculations in the sample. You see the product vibrate. This is with the backlight on. There's the backlit image, lights flash, and there's the final image. As quick as that, we've made those calculations, and we're finished with the sample. Take the sample off. The image and all the information is saved locally and written to the plant data system. We want to make it as easy as possible to verify the results. We put a green dot on every object that we count as a single bean. If we had two beans very close together and the imaging system could not separate them, we put a yellow dot on to indicate two beans. If we find a cluster of three, it gets a red dot. This visual verification gives the operator immediate feedback, and you can be assured that the count is what we say it is. Rod Stewart was right. Every picture does tell a story. So we document the mean and standard deviation for every geometric property we can measure. We want to capture the complete story for this sample, this and every sample. Although treatment adheres to soy more easily than to corn, we find that our treatment scoring process works very well on corn, with one significant difference. Treatment does not adhere to the germ of the kernel. So when we look at the corn kernel, we find the white areas, we remove those white areas from the picture, and then we make the same comparison of, in this case, the yellow corn versus the green treatment, and that's what gives us the color data that we need to assess splotchy, as you see some here, or very even coverage, except for the areas that are white, the germ areas. As with soy, we also have different recipes for different treatment colors in corn. You see here a purple sample, purple treated sample. We have the same no treatment on the germ area, and we have some kernels that are well covered and other kernels that are not so well covered. So we're going to have good statistics on this as well. The move to polymer additives in coatings has changed the appearance of the treated sample dramatically. Everything looks better now. But looks can be deceiving. What is hidden below the gloss in the coating? Our video conditioning process eliminates this glare from the polymer coating and allows the same scoring process to be used whether the treatment is glossy or not. You can see that the image looks very much the same as a non-polymer treatment, but that's because we've removed the gloss. In this side-by-side comparison, if you focus on a bean on the right-hand side, look at that same bean on the left, you're going to see very much the similar picture. If you focus on a bean that's poorly treated, it may have a little bit less gloss in the other image, the untreated image, let's say, but there is still a significant difference in the treatment, and our measuring process picks that up. That's the end of the presentation. We look forward to learning more about your process and showing you how the OptiCount can add value in your operation. Thank you very much.